Warmly welcome all of you. This BCom Special Degree Part 1, COM1341 Microeconomics. This is session 4. Today we are going to discuss government intervention to the market economies. Lesson objectives. You will learn how imposition of tax affect price, production, consumer surplus, producer surplus, and social welfare. We will discuss economic implications of tax on production, consumer surplus, producer surplus, and social welfare or deadweight loss of tax. Then you will learn how a subsidy granted by the government affect price of the production, quantity of the production, consumer surplus, producer surplus, and social welfare. Again, you will learn when price is controlled. When price is controlled by the government, how price, production, consumer surplus, producer surplus, and social welfare are affected. We discuss economic implications of price control on price of the products, quantity produced, consumer surplus, producer surplus, social welfare, and so on. Then economic implications of deficiency payment system and purchasing excess supply by the government. When government introduce minimum price ceiling, government has to implement extra policy to rescue the minimum price ceiling. There are two methods that can be used for this purpose. One is called deficiency payment system. The other one is called purchasing excess supply by the government. They are the two methods which can be used by the government for the success of minimum price ceiling. Now I would like to focus on our main topics today, that is government intervention to the market forces. Government intervene to the market by imposing taxes, by providing subsidies, implementing maximum price, implementing minimum price, and there are other methods of government intervention such as introducing production quota and imposing tax on imports and imposing quotas on imports and export as well as. Then imposing tax on goods and services. Tax can be imposed in the form of either lump sum tax per unit tax, or it is called unit tax. A lump sum tax rate is a fixed tax rate per unit of commodity. Government collects fixed amount per unit of commodity as a tax. It is called unit tax or lump sum tax. The other form of tax is called Agualarum tax. And Agualarum tax is a proportional tax rate imposed as a percentage of the commodity price. Therefore, it is called percentage tax. Agualarum tax or percentage tax. Unit tax and percentage tax. Then I would like to focus on both together, lump sum tax and Agualarum tax on producers. I would like to discuss first economic implications of lump sum tax on producers. This is the initial demand curve of this commodity, dx, initial supply curve, sx. Then initial equilibrium occur at point E. Initial equilibrium price is given by P0, quantity produced is given by Q0. Now let us assume that government impose a lump sum tax on this commodity. As a result, supply curve shift leftward by the amount of tax because cost of production increases with the imposition of lump sum tax. That is why supply curve shift to the leftward by the amount of tax. After tax, new equilibrium occur at point E1 with equilibrium price P1 and equilibrium quantity Q1. This equilibrium price is the price paid by buyers. Therefore, it is called buyer's price. Then what producers get is called suppliers or producers price. It is given by P2. The difference between P1 and P2 is the unit tax on this product. Then government collect tax up to Q1 unit of this product. Therefore, tax revenue collected by the government is given by the area of B plus C plus H plus G. Now I would like to discuss economic implications of this lump sum tax. Before lump sum tax, consumer surplus is given by the area of A, B, C, D. A, B, C, D. After tax, consumer surplus is given by the area of A. Then reduction in consumer surplus is given by the area of A, C, D. Then producer surplus before tax is given by the area of J, I, H, G, F. After imposition of lump sum tax, producer surplus is given by the area of I plus J. Then reduction in producer surplus is given by the area of H plus G plus F. Now I would like to explain deadweight loss or social cost of this tax policy. That is what no one can captured by this policy. It is given by the area of D plus F. I would like to explain how we estimate this deadweight loss area. When you reduce reduction in consumer surplus and reduction in producer surplus, then you will get the social cost of this tax or deadweight loss. This is the government tax collection B plus C plus H plus G. You have to reduce B, C, D, and you have to reduce again H, G, F. In other words, plus B, plus C, plus H, plus G. Then you reduction in consumer surplus, then you will get minus B, minus C minus D. When you reduction in producer surplus, then you will get minus H minus G minus F. Then you can cancel out negative terms for positive terms. Then you will get negative or minus D and minus F. That is called lump sum tax. I would like to explain economic implications of ad valorem tax at this point again. Ad valorem tax on producers. Initial supply curve is given by Sx. Initial demand curve of this commodity Dx. Then equilibrium occur at point E with equilibrium price P0, quantity Q0. Then consumer surplus is given by the area of A, B, C, D. Then producer surplus is given by the area of I, J, H, G, F. Now we assume that government impose an ad valorem tax on producers, percentage tax. Then the amount of tax rises as price of the product rises with ad valorem tax. That is why new supply curve after tax rotates toward the vertical axis by the large amount at higher prices and small amount by small prices. But economic implications of both are similar. Then I would like to explain consumer surplus after this ad valorem tax on producer. Consumer surplus is given by the area of A. Reduction in consumer surplus is given by the area of B, C, D. Producer surplus is given by the area of I plus J. Then reduction in producer surplus is given by the area of H plus G plus F. Then deadweight loss or social cost of this policy is given by minus D minus F. Again, you can estimate reduction in social welfare by reducing reduction in consumer surplus and reduction in producer surplus from the government tax revenue. That is plus B plus C plus H plus G minus B minus C minus D minus H minus G minus F. When you cancel out positive values for negative values, then you will get the last value as minus D and minus F. That is the social cost of this policy or deadweight loss. I would like to explain again what I have explained so far without these two diagrams. A lump sum tax and ad valorem tax on producers. The market demand and supply curves are given by Dx and Sx respectively in both diagrams. Equilibrium price and quantity of both diagrams are given by P0 and Q0 respectively. You can see equilibrium price, equilibrium price, equilibrium quantity, equilibrium quantity. Then when government impose a lump sum tax on producers, the supply curve shifts to the leftward parallelly. When government impose lump sum tax, supply curve after tax shifts leftward parallelly. Supply curve after tax is given by Sxt. Supply curve after tax Sxt. New equilibrium occur at point E1, determining equilibrium price P1. This is the price paid by buyers. Equilibrium price P1, this is the price paid by the buyers. Right. Then lump sum tax again. The price received by producers or suppliers, PS is P2, suppliers price, what suppliers get from the market. In the lump sum tax, the difference between these two prices, that is P1 minus P2, shows the tax per unit. Unit tax is given by the difference between equilibrium price and supplies price. When government impose an Agualarum tax, when government impose an Agualarum tax, the supply curve rotates from X to XT. In this case, supply curve rotates, not shift. The rotation is in a manner, that a smaller degree at lower prices, and by a larger degree at higher prices, as I mentioned earlier. All the other economic implications of Agualarum tax is similar to the lump sum tax. That is what I have already explained. Then economic implications of tax on producers. I would like to summarize what I have so far discussed with the help of demand and supply curves. Now I would like to focus your attention on reduction in consumer surplus. Reduction in consumer surplus is given by the difference between new surplus and old surplus. New surplus is given by A, old surplus is given by A, B, C, D. The difference between these two is minus B, minus C, minus D. This minus sign highlighted the reduction in consumer surplus. Then again, reduction in producer surplus, new surplus, and old surplus. New surplus and old surplus. When you reduce cost or variable cost from the revenue, then you will get producer surplus, new surplus. Total revenue I, J, K. You have to reduce variable cost K. Then you will get I plus J, that is new surplus. Old surplus, producer's income H, G, F, I, J, K, L. Cost of production K, L. The difference between producer's income and cost of production is the producer's surplus. All surplus is given by H, G, F, I, J. Then change new surplus I plus J, all surplus H, G, F, I, J. When you cancel out positive figures with negative figures, you will get the reduction in producer surplus, that is minus H, minus G, minus F. Then economic implications of tax on producers continue. Okay, now tax revenue collected by the government. As I explained, by the help of our previous diagram, tax revenue collected by the government is given by the area of B, C, G, H. Then you will be able to measure deadweight loss of this tax policy. That is given by government tax revenue reduced by reduction in consumer surplus and reduction in producer surplus. When you reduce reduction in consumer surplus and reduction in producer surplus from the government tax revenue, then you will get the deadweight loss of this tax. Government tax revenue is given by BCGH. Reduction in consumer surplus is given by the area of BCD. Reduction in producer surplus is given by HGF. Then you can cancel out positive terms with negative terms. Then you will get minus T minus F as deadweight loss, as I explained with the help of previous diagram. Then I would like to discuss numerical example for lump sum tax on producers. Now I would like to explain lump sum tax with demand and supply equation. The demand equation QDX equals 250 minus 5x. Then supply equation QSX equals minus 50 plus 5px. By solving these two equations together for P, you will get the equilibrium price. That is Px equals 30. When you substitute equilibrium price for Px of either equation, then you will get equilibrium quantity QDX as 100. Now suppose that government has imposed a unit tax of 10 rupees on producers of this product. When government imposes a unit tax, we can derive the supply curve after tax by reducing unit tax from the price of the product. Here QSXT, quantity supplied of commodity X after tax, equals A plus B Px minus T. In this example, unit tax is 10 rupees. Therefore, we can substitute 10 rupees for this T. You can see QSXT equals minus 50 plus 5 Px minus 10. When you remove the bracket, then you will get QSXT equals minus 50 plus 50, 5 Px minus 50. Then you will get supply curve after tax. QSXT equals minus 100 plus 5x. By using this new equation of supply after tax and initial equation of demand for this product, you will get the new equilibrium price after tax. This is the demand curve, 250 minus 5 Px. This is the new supply curve. Then when you solve this equation for P, then you will get equilibrium price as 35 rupees and equilibrium quantity as 75. Then numerical example for Agualarum tax on producers. Now we are going to discuss one numerical example for Agualarum tax on producers. The demand and supply functions are given below. This is the demand equation. QDX equals 300 minus 2PX. This is the supply curve. QSX equals minus 120 plus 2PX. Suppose that government impose an Agualarum tax on producers. This Agualarum tax also affect on supply curve. Price after tax, PT, price after tax, would be equal to price of commodity X, that is initial price, plus tax. In this case, tax is collected from the price of the product as a percentage tax. Therefore, we multiply initial price by tax rate. Then you will get the value of tax. When you add value of tax to the price of the product, then you will get price of the product after tax. Okay, that is PX plus PX into T percentage, Agualarum tax rate. Then you can take common terms out. Common term PX. When we take common terms out, you will get 1 plus T percentage within bracket. Then you can see price after tax, PT, would be equal to PX equal to PT, price after tax, over 1 plus T percentage. What is that? After tax, price of the commodity would be equal to PT over 1 plus T percentage. Now you can substitute P over 1 plus T percentage for the price of the product. Then you will get supply curve after Agualarum tariff. According to the given information of demand and supply functions, equilibrium price and equilibrium quantity are given by Px equals 105, Qdx equals 90. That is the equilibrium price 105, equilibrium quantity 90 units. By solving these two equations, you would be able to calculate equilibrium price and equilibrium quantity of this commodity X. Then suppose that government impose 100% Agualarum tax on producers. Then supply function will be, as I mentioned earlier, QSXT, quantity supplied of commodity X after tax, would be equal to A plus B. Instead of Px, we substitute PT over 1 plus P percentage, 1 plus T percentage. Right, now you can see this is the initial supply curve minus 120 plus 2 is the initial supply curve Px. Now after tax, we substitute PT over 1 plus 0.1 for Px. What is PT? Price after tax divided by 1 plus percentage tax. 10% mean 0.1. Now you can see QSXT equals minus 120 plus 2T 2PT over 1.1, that is 1 plus 0.1, that is 1.1. By using this equation with the initial demand curve, you will get the new equilibrium price and quantity after ad valorem tax of 10%. Equilibrium price Px equals 110, equilibrium quantity 8 units. You can understand how equilibrium price and quantity change after government impose an ad valorem tax on producers. The graphical presentation of the above numerical example of ad valorem tax on producers. Now I would like to make a graphical presentation of the above ad valorem tax. This is the initial supply curve, this is the initial demand curve as given by the demand and supply functions. Then equilibrium occur at point E. Equilibrium occur at point E. Equilibrium price before ad valorem tax is 105, equilibrium quantity 90. After 10% ad valorem tariff on commodity X, the supply curve shifts from Sx to Sxt. Then equilibrium occur at point E1 with equilibrium price 110, that is what purchasers pay, and equilibrium quantity 80, the price get by suppliers 100. This area measures the government tax revenue. This is the consumer surplus after tax. This is the reduction in consumer surplus after tax, BCD. This is the producer surplus after tax, IJ. Reduction in producer surplus after tax is given by HGF. You can understand how supply curve rotate after ad valorem tariff as we earlier discussed. Then economic implications of numerical examples of ad valorem tax on producers. This is what I have so far explained with the help of previous diagram. Consumer surplus before government tax, A, B, C, D. Consumer surplus after government tax, A. I have measured numerical values of these changes. Consumer surplus before government tax is given by 150 minus 105. This is the price at 0 demanded, and this is the equilibrium price. The difference between quantity demanded, the price between price at 0 quantity demand and equilibrium price into equilibrium quantity divided by 2, then you will get reduction in then you will get consumer surplus before government tax 2025. Then consumer surplus after government tax. Consumer surplus after government tax is given by the area of A. It is given by the price difference 150 minus 110 into new quantity after tax, then divided by 2. Then you will get consumer surplus after tax as 1,600. Then producer's surplus before government tax is given by the area of H, G, F, I, J. It is measured by the price difference. This is the equilibrium price. This is the quantity demand. This is the price at quantity supplied of 0. This price difference is multiplied by the initial equilibrium quantity and divide by 2. Then you will get producer surplus before government tax as 2025. Then producer surplus after tax is given by I plus J. Producer surplus after tax. That is the price difference into new equilibrium quantity divided by 2. Then producer's surplus after government tax is given by 1,600. Similarly, we can measure government income from tax. That is given by the area of B plus C plus G plus H. It can be numerically measured by multiplying quantity supplied after tax by tax per unit. Tax per unit is 10 into 100, then 800. That is the government income from taxation. Then consumers' tax burden. What consumer incur from the tax is called consumer tax burden. That is given by the area of P plus C. That is given by the price difference into equilibrium quantity after tax. Then 110 minus 105, that is 5 into 8, 400. Consumer tax burden 400. Similarly, we can estimate producer tax burden. That is given by the area of H plus G. Again, price difference, equilibrium price and producer's price. 5 into equilibrium quantity after tax equals 400. Producer's tax burden 400. Economic implications of numerical example of Agualarum tax on producer. Now I would like to summarize economic implications of numerical example of Agualarum tax on producers, what we have so far discussed, either by using graphical explanation or equations. Social loss of producer surplus due to tax. Social loss of producer surplus due to tax. Producer surplus before tax minus producer surplus after tax minus producer tax burden. That is given by F. Then social loss of consumer surplus due to tax. Consumer surplus before tax, consumer surplus after tax. That is consumer tax burden, that is given by F. These are the two areas of deadweight loss of this tax. This from the producer side, this from the consumer's side. Then social cost of deadweight loss, this the consumer side, this the producer side, as I explained earlier. Then total deadweight loss is the summation of tax burden on producers and tax tax burden on consumers. 20 plus 20 equals 50. Then lump sum tax and ad valorem tax on consumers. Now I am going to explain economic implications of lump sum tax and ad valorem tax on consumers. When government impose a lump sum tax on consumers, price of the product increase. As a result, demand curve shifts downwards parallelly by the amount of lump sum tax. I would like to first discuss economic implications of lump sum tax on consumers. Initial demand curve is given by D0, supply curve is given by S. Initial equilibrium occur at point PC. Initial equilibrium occur at this point, intersection point of demand and supply. Then equilibrium price is P0, equilibrium quantity is Q0. When government impose a lump sum tax on consumers, demand curve shift downward from D0 to D1 as given in the red straight line demand curve. Then new equilibrium occur at this point. Then equilibrium price is PS, equilibrium quantity Q1. Then this is the price paid by producers. This is the price paid by buyers. This is the price get by suppliers. Then before a lump sum tax on consumers, consumer surplus was given by the area of A, B, C, D, E. With this lump sum tax, consumer surplus is given by the area of A, B. Then reduction in consumer surplus due to lump sum tax on consumer is given by the area of C plus D plus E. Again, before a lump sum tax on consumer, producer surplus is given by the area of I, F, G, H. After lump sum tax on consumers, producer surplus is given by the area of I. Then reduction in producer surplus is given by the area of F, G, H. Similar to our previous discussion. Then social cost of this lump sum tax on consumer is given by the area of E plus G. Again, it is given when you reduction in consumer plus surplus and reduction in producer surplus from the government tax revenue. Government tax revenue is given by the area of C plus D plus F plus G. You have to reduction in consumer surplus, that is minus C, minus D, minus C, and you have to again reduction in producer surplus, that is minus F, minus G, minus H. When you cancel out positive terms with negative terms, then you will get minus E and minus H as deadweight loss or social cost of lump sum tax on consumers. Then I would like to focus on an ad valorem tax on consumer and ad valorem tax on consumers. When government imposes an ad valorem tax, demand curve rotates to the price axis. Rotate, not shift. Demand curve rotate toward the x-axis by a large amount at higher prices than lower prices. Let us take initial demand curve D0 and initial supply curve S. Initial equilibrium occur at the intersection point of D0 and S0 with equilibrium price P0, equilibrium quantity Q0. Then consumer surplus is given by the area of D1, B, C, D, E. Producer surplus is given by the area of I, F, G, H. Now, when government impose ad valorem tariff on consumers, demand curve rotates from D0 to D1. D1. Then new equilibrium occur at this point with price PS and quantity Q1. Then consumer surplus is given by P, then reduction in consumer surplus C, D, E. Initial producer surplus is given by I, F, G, H. New producer surplus is given by I. Then reduction in producer surplus is given by F, G, H. Then social cost or deadweight loss of ad valorem tariff or tax on consumers is given by the area of EH. Again, it is measured when you reduce reduction in consumer surplus and reduction in producer surplus from the government tax revenue. Government tax revenue is given by C, D, F, G. Reduction in consumer surplus is given by minus C, minus D, minus C. Reduction in producer surplus is given by minus F, minus G, minus H. When you cancel out positive terms with negative terms, you will get minus E and minus H as social cost or deadweight loss of this policy. Then, economic implications of tax on consumer by using equations. Reduction in consumer surplus. Reduction in consumer surplus is the difference between new surplus and old surplus. New surplus is given by the area of A plus B. Old surplus is given by the area of A, B, C, D, E. This difference is the reduction in consumer surplus change. Minus C, minus D, minus E. Then reduction in producer surplus. Again, new surplus and the difference between new surplus and old surplus. As I earlier explained, producer surplus is the difference between producer's revenue and variable cost. Then old surplus is the difference between producer's income and cost of production. Before tax on consumer, producer's income was given by the area of F, G, H, I, J, K, L. Then cost of production was K, J, L. When you reduce cost of production from the producer's surplus, producer's income, then you will get producer's surplus. Again, when you reduce variable cost of production from the producer's income, then you will get producer's surplus. This is the new surplus. This is the old surplus, the difference between new and old, then you will get reduction in producer surplus, that is minus F minus G minus H. Then tax revenue collected by the government, as I mentioned or explained by the help of diagram, tax revenue collected by the government is given by the area of C plus D plus F plus G. Then deadweight loss of this tax policy. Deadweight loss can be measured by reduction in consumer surplus and reduction in producer surplus from the government tax revenue. This government tax revenue CDFG. We reduce reduction in consumer surplus CDE, and we reduce reduction in producer surplus. When you remove bracket, you will get minus C minus D minus C. Again, when you remove this bracket, we have to multiply by minus sign, then you will get minus F minus D minus H. Then you can cancel out positive values for negative values. Then you will get minus C and minus H as deadweight loss. Then I would like to discuss with you the other way of government intervention, that is subsidy. A production subsidy may be in the form of financial grant or in the form of input subsidy. Government can produce or grant supply in two forms. One is in the form of financial grant or in the form of input subsidy as fertilizer subsidy for the farmers. Also, subsidies can be given to the producers as tax relief, tax holidays, and concessional credit facilities. These are the type of subsidies granted by government in addition to financial grant or input subsidy. Tax relief, also one form of subsidy. Tax holidays, concessional credit facilities also treated as subsidy. In the analysis, production subsidy can be treated as negative tax. Production subsidy can be treated as negative tax or reduction in tax. Negative tax mean it effects on production and price is just reverse to that of tax. Its effects on production, that is negative tax or subsidy. Price is just reverse to that of tax. Subsidies are provided in the form of unit subsidy or percentage subsidy of both producers and consumers. As we discussed earlier, in the case of tax, we can discuss subsidies on producers and consumers and both Agualarum and lump sum or unit and percentage subsidies. When government provides subsidy for producers, supply curve shift to the rightward because cost of production falls. I would like to explain economic implications of subsidy. I would like to take first unit subsidy. Initial supply curve of commodity X is given by Sx, this line. Initial demand curve is given by Dx. Initial price, equilibrium price is given by P0, equilibrium quantity is given by S0. Then consumer surplus is given by the area of AB. Producer surplus is given by the area of GH. Now we assume that government grant subsidy on producers. As a result, in the case of unit subsidy, supply curve shifts to the rightward parallelly by the amount of unit subsidy. New supply curve after subsidy is given by SS line, given in red line. New equilibrium occur at the point of intersection of SS and DX with equilibrium price P1 and equilibrium quantity Q1. Equilibrium price P1, that is what purchasers pay, buyer's price. But government grant unit subsidy, as a result, producers get higher price for this product than the market price. Then supplier's price PS is equal to P2. This is the initial equilibrium price. This is the price. P1 is the price paid by buyers. This P2 supplier's price. The difference between supplier's price and buyer's price, or difference between P2 and P1, is the unit tax granted by the government on this commodity. Then government subsidy or cost of government subsidy is given by the area of B, C, D, E, F, G. This is the unit tax government grant the subsidy for the amount of Q1. Then cost for the unit subsidy is given by the area of B, C, D, E, F, G. Okay. Now you can see this, the P1 is the buyer's price. Now purchasers pay lower price than the equilibrium initial price. Therefore, now consumer surplus is given by the area of this triangle. A, B, G, F, E, that is the consumer surplus after this subsidy. Again, this is the price what producers or suppliers get. Therefore, producer surplus also increase up to this area. Now, producer surplus is given by the area of H, G, F, B, C. Again, C, B, G, H is the producer surplus. Now, you can see reduction in producer surplus is given by the area, increase in producer surplus due to subsidy is given by the area of BC. Producer surplus before supply is given by the area of HT. New producer surplus after subsidy is given by the area of HGBC. Then increase in producer surplus is given by the area of B plus C. This is the cost of subsidy. This is the increase in producer surplus. This is the reduction in, this is the increase in producer surplus. This is the increase in consumer surplus. I would like to explain again. This is the government cost for the subsidy program B, C, D, E, F, G. Then increase in producer surplus is given by the area of B plus C. Then increase in consumer surplus is given by the area of G, F, E. Then social cost or deadweight loss of the subsidy program is given by the area of D. How do we measure cost of subsidy program? We reduce cost of subsidy program from the increase in producer surplus and increase in consumer surplus. Increase in producer surplus is given by the area of B plus C. Increase in consumer surplus is given by the area of G plus F plus E. Then you can remove cost of this program B, C, D, E, F, G from those two areas. Then you will get social cost of this program. This subsidy on producers, that is unit subsidy. Now I would like to discuss Agualarum subsidy on producers. When government grant Agualarum subsidy or percentage subsidy on producers, supply curve rotates toward the quantity axis or horizontal axis by a large amount at higher quantities. Initial supply curve is given by Sx, initial demand curve is given by Dx, then initial equilibrium price P0, quantity Q0. Initial consumer surplus is given by the area of A plus B. Producer surplus is given by the area of G, H. After government grant Agualarum subsidy on producers, supply curves of rotate from Sx to Ss. Ss mean supply curve after subsidy, then new equilibrium, price is P1, quantity is Q1. Now, consumer surplus is given by the area of A, B, G, F, E. Producer surplus is given by the area of H, G, P, C. Then increase in producer surplus is given by the area of B plus C. Increase in consumer surplus is given by the area of G, F, E. Then again deadweight loss of this subsidy program is given by the area of D. How do you get social cost of this Agualarum subsidy on producers? You have to reduce cost of subsidy from the increase in producer surplus and increase in consumer surplus. That is B plus C plus D plus F plus E minus B minus C minus D minus C minus F, then you will get minus D. Right. Without diagram, I would like to repeat what I so far explained for your easier understand. Initial demand and supply curve before subsidy are given by Dx and Ss respectively. Equilibrium price and equilibrium quantity before subsidy is given by P0 and Q0 respectively. Then after subsidy, new equilibrium price bias pay is P1 and equilibrium quantity Q1. The price what suppliers get is P2. In an unit subsidy, now I would like to refer to the Agualarum subsidy or unit subsidy. The supply curve shift to the rightward parallelly. You can remember how I explained. The difference between these two prices, P1 and P2, shows the subsidy per unit. In a percentage subsidy, the supply curve rotates from Sx to Ss as I saw earlier. The rotation is in a manner that a smaller degree at lower prices and by a larger degree at higher prices. All the economic implications of unit subsidy is similar to the economic implications of percentage subsidy. All the economic implications of unit subsidy is similar to the economic implications of percentage subsidy, as we discussed earlier. Then economic implications of subsidy on producers. I would like to summarize what we have so far discussed with the help of our previous diagram. Increase in consumer surplus. Again, the difference between new surplus and old surplus. All surplus, all consumer surplus, all surplus means before subsidy is given by the area of A plus B. New surplus, as you can remember, new surplus is greater than all surplus. New surplus is given by the area of A, B, G, F, E. Then difference between all surplus and new surplus is positive G, positive F, positive E. Increase in consumer surplus is given by the area of G, F, E. They are positive because it is increase. Then increase in producer surplus. Again, that is the difference between new surplus and old surplus. As I mentioned earlier, producer surplus is the difference between producer's income or revenue and variable cost. New surplus is measured by reducing variable cost from the producer's income. Producer's income is given by the area of B, C, D, E, F, G, H, I, J, K, L. Then variable cost of production, I, J, K, L, K, E, F, D. Then when you cancel out positive term with negative terms, you will get B, C, G, H. That is the increase in producer surplus. All surplus, producer's income minus variable cost, producer's income H, G, F, I, J, variable cost I, J, E, then all surplus H, G. Then the difference between all surplus and new surplus is the increase in producer surplus, that is B plus C. Again, that is positive because it is increase in producer surplus. Then cost of subsidy, that is incurred by the government, that is given by the area of B, C, D, E, F, G. Then deadweight loss of subsidy is again measured by reducing cost of production, cost of subsidy by the increase in consumer surplus and increase in producer surplus. Increase in consumer surplus is given by BC. Increase in producer surplus is given by GFE. Then you can reduce cost of subsidy B plus C plus D plus E plus F plus G. Then when you cancel out positive terms with negative terms, then you will get minus D as deadweight loss of subsidy or social cost of subsidy. Then numerical example for percentage production subsidy. You are given the demand and supply functions below. Demand curve QDX equals 37 minus 2 PX. Supply equation QSX equals minus 5 plus 4 PX. By using these demand and supply equations, you can estimate equilibrium price and equilibrium quantity. Then you will get equilibrium price 7 rupees and equilibrium quantity 23 units. If government provide 20% subsidy for the producers, supply functions will be A plus B, Px over 1 minus percentage supply. As in the case of tax, we have to get the price after subsidy. Price after subsidy is the equilibrium price divided by 1 minus percentage subsidy. In the case of Agualarum tax, you can remember Px over 1 plus T percentage, here 1 minus S percentage, that is the difference. The same way what we did in the case of Agualarum tax. We can get price after subsidy by adding subsidy to the initial price of the product. This is the way how we get supply curve equation after subsidy. By substituting numerical values for our previous demand and supply curve, we will get equilibrium price and quantity after subsidy. This is the initial supply curve QSX equals minus 5 plus 4 PX. We substitute this part for Px. That is why you get minus 5 plus 4 Px over 1 minus 0.2. That is 20%. 20% means 0.2 minus 0.2. Then you will get 0.8. Minus 5 plus Px over 0.8. Then you will get supply equation after subsidy as minus 5 plus 5 Px. Then new equilibrium price and quantity after subsidy. As I mentioned, you can measure. Then this is the supply curve after subsidy, minus 5 plus 5 Px. This is the demand curve. This is the initial demand curve. 37 minus 22 Px. Then you will get equilibrium price after subsidy 6, quantity 25. I would like to explain what we have so far discussed with the help of demand and supply equations, now with the demand and supply curves. This is the initial supply curve, this is the initial demand curve, this is the initial equilibrium price, initial equilibrium quantity. Then this is the initial consumer surplus AB, producer surplus IE. After 20% Agualarum subsidy, supply curve rotate from S to SS, then new equilibrium price 6, equilibrium quantity 25. This is the price what suppliers get 7.5. This is the consumer's price or buyer's price 6. The difference between 7.5 and 6 is the Agualarum tax at quantity equals 25. Then due to this subsidy, consumer surplus increase from A plus B to A plus B plus E plus G plus F. Producer surplus also increase from IE to I, E, G, B, C. Then social cost of tax or deadweight loss is given by minus D minus H. That is, again, we reduce increase in producer surplus and increase in consumer surplus from the subsidy cost of the government. Then Economic implications of numerical example of percentage subsidy for producers. Consumer surplus before subsidy A plus B. We can measure the value of the area of A plus B by numerically. This is the price change, this is the quantity, the difference between these two prices into quantity divided by 2, then consumer surplus before subsidy is 132 rupees 0.25. Consumer surplus after subsidy is given by the area of A, B, E, F, G. It can be measured by the price difference into quantity divided by 2. Then you will get 156.25. Then producer surplus before subsidy is given by the area of E plus I. It is also can be measured numerically. Then you will get 66.125. 66.125. Then producer surplus after subsidy, that is B, C, E, I. It is also can be measured numerically. Then you will get 78.125. Then government subsidy cost of subsidy program is given by the area of B, C, D, E, F, G, H. That is the price difference into equilibrium quantity. Then you will get 37.5. Then total welfare or deadweight loss minus D minus H. You can measure the value of this area as 1.5. Okay, social cost around arose from the produce side minus D, social cost arose from consumer side minus H. You can measure numerical values for the social cost around from produce side minus D and social cost arose from the consumer side, that is minus D, as 0.1 and 1. Subsidy for consumers. Government provides subsidies for consumers. This is known as consumption subsidy. In an unit consumption subsidy, demand curve shifts upward, and in a percentage consumption subsidy, the demand curve will be rotated from left to right. This is the unit subsidy. When consumers are provided unit subsidy, demand curve shifts upward by the amount of unit subsidy. The initial demand curve is given by D0. Initial supply curve is given by S. Initial equilibrium price P0. Initial equilibrium quantity Q0. Then initial consumer surplus AC. Initial producer surplus IH. Then after unit subsidy on consumers, demand curve shift from D0 to D1. Then equilibrium price PS, equilibrium quantity QS. Then suppliers price PS, purchases price PB. Then the difference between suppliers price and buyer's price is the unit subsidy. Then total cost for this unit subsidy is given by the area of C, D, E, F, G, H. Then again, social cost or deadweight loss of this unit subsidy is given by the area of E. That is the reduction of cost of subsidy from the increase in consumer surplus and producers surplus. Then I would like to focus your attention on percentage subsidy. As I mentioned earlier, when government grant percentage subsidy, demand curve rotates toward the upward by a higher amount at higher prices and by a lower amount at lower prices. Initial supply curve is given by S. Initial demand curve is given by D0. Initial equilibrium price is P0. Quantity is Q0. Then initial consumer surplus AC, producer surplus HI. When government grant percentage subsidy, demand curve rotates from D0 to D1. Then equilibrium occur, equilibrium price PS, equilibrium quantity QS. Then consumer surplus increase by the amount of HGF. Producer surplus increase by the amount of C plus G. Then this is the total cost of subsidy granted by the government, C, D, E, F, G, H. This is the increase in producer surplus. This is the increase in consumer surplus. This is the social cost or deadweight of this percentage subsidy program. Again, we can summarize economic implications of subsidy for consumers. Increase in consumer surplus, that is the new surplus, and that is the difference between new surplus and old surplus. New surplus is given by the area of A, C, H, G, F. Old surplus is given by the area of AC. The difference H, G, F is the increase in consumer surplus. Then increase in producer surplus. Again, the difference between new surplus and old surplus, as I mentioned earlier, producer surplus is the difference between total revenue and total variable cost. This is the total revenue of the producer. This is the total variable cost. This is the new producer surplus. This is the old producer surplus. This is the total revenue. This is the total variable cost. This is the total old surplus. Then difference between old and new is C plus D. That is the increase in producer surplus. Then cost of subsidy is given by the area of C, D, E, F, G, H. Then deadweight loss of subsidy is given by the area of E. Area of E. That is the difference between increase in consumer surplus and producer surplus and reduction in subsidy cost of the government. That is minus E. Have a nice day. Thank you.